Endochondral ossification is a step-by-step process in which a hyaline cartilage model of a bone is turned into osseous tissue. We start with a fetal tissue called mesenchyme, which develops into hyaline cartilage in the location of a future bone. The perichondrium of the cartilage eventually begins producing osteoblasts, which are bone-producing cells. These osteoblasts secrete bone matrix around the middle of the cartilage model, forming a bony collar that will become the diaphysis. Meanwhile, the chondrocytes, or cartilage cells, in the middle of the model begin to enlarge. This forms what's called the primary ossification center. The chondrocytes get so large that they form a cavity in the middle of the model. Blood vessels penetrate the area and bring stem cells into the cavity. The cavity then spreads throughout the model and becomes the primary marrow cavity of the future diaphysis. The stem cells give rise to osteoblasts and osteoclasts. Osteoblasts line the cavity and begin to calcify cartilage, forming a temporary network of trabeculae. As the bony collar expands throughout the diaphysis, osteoclasts break this calcified tissue down, hollowing out the marrow cavity. Soon after this process begins, secondary ossification centers begin to form at the ends of the model in the same way the primary center formed. Each end will become an epiphysis, filled with spongy bone. The epiphyses have their own blood supply and maintain a cartilage ring around themselves, the cap of which becomes the articular cartilage of a joint. The cartilage separating the epiphysis from the diaphysis is the epiphyseal growth plate that allows these bones to grow in length until early adulthood.